Okay, so welcome everyone. We're ready to start, I think, for this very exciting panel on natural language processing. I'm Andres. I'm one of the co-organizers of RIA. I'm doing my PhD at MIT. Victor Jimenez is going to be helping us with the chat. He's also one of the organizers. We'll have 5 incredible speakers. Our time is a bit tight, so I'll ask the speakers to try to stick to their 10-minute limit per person for presentation. We will try to ask at least one question after each presentation, and then we hopefully will have some time for general questions at the end. We'll be using Menti for questions. So Victor just pinned the comment in the chat. There you can put your questions, or you can put them in the chat and Victor will put them there, and you can vote to see what are the most liked questions. If you double click on any of the screens, including the share screens, it gets bigger, and there's an arrow on the top right which can make you minimize the chat to further increase the screen. So let's begin, and I'm very glad to have Mariama and Aisha presenting. I hope this can help to foster relationships between the African community and the Latin American communities. I think there are many things in common that we share. Mariama Drame graduated from the African Master in Machine Intelligence, AMMI, at the African Institute of Mathematical Sciences in Rwanda. She graduated also before with a bachelor degree in software engineer at the Gaston Berger University in Senegal, where she's from. And last fall, we were companions in Facebook at a Facebook AI research internship in London. So that's where we became friends. And so I'm very happy that you came here. And then she was at Hugging Face Paris for 6 months. And now she's back at Senegal working in a startup, and her interests are in natural language processing. And Aisha Alaagib, I hope I'm pronouncing that right, is a teaching assistant at the African Masters in Machine Intelligence at Ghana. And she's a graduate student advised by Mustafa Cissé. She also graduated from the African Master in Machine Intelligence. She has another master's in mathematical sciences. And she graduated from the University of Khartoum in Sudan. And she was a research intern at the Vector Institute, and she works on multimodal learning, so slightly different than NLP. So I'm very glad that you were able to come. I do not see Aisha right now. Maybe she...
Actually, I can't see Aisha anymore.
Okay, so if that's the case, we can start with the next speaker, with Francisco maybe, and then we can come back to your presentation. There's no, the okay. Order doesn't really matter. So Francisco Guzman, we hadn't met. He's a research scientist at Facebook Applied Machine Learning. He got a PhD from Monterrey. He then got a postdoc in the Qatar Computing Researcher Institute. And his work lies at the intersection of language technologies, statistics, and machine learning. So please, Francisco, I'll give you a 2-minute warning just in my screen. Yeah, so just try to take around 10 minutes. Thank you.
Okay. Thank you, everyone. Thank you for the invitation. I really appreciate to be here. Again, my name is Paco Guzman. I'm a scientist manager at Facebook AI, where I work in translation. And I'm really honored to be here connecting with people from Mexico and Latin America and other parts of the globe. And today my talk is mostly about the challenges of connecting people across language barriers, specifically in low resource settings. If you're familiar with Facebook, you've probably seen this feature where when there's content in another language, we offer the possibility to see translation in your language of preference. This allows you to really connect with the people you care about and with the content they're using in your own language. Right now, we have around much more than 6 billion daily translations, and these come across the different Facebook surfaces like Facebook feed, Messenger, Instagram, and Workplace. And this is working really, really well for languages for which we have very large resources, like French, like Spanish, like German. But the thing is, we need to connect people across the globe, not just for a few languages. So what happens when we try to translate into languages that have fewer resources? So this is the point of this talk. Now, it's important because once we moved to deep learning systems, neural machine translations have been identified as having a larger, steeper learning curve in low resource scenarios. That means that they require many more training instances to be able to do a good job in translating. The problem is that if you plot all the data, the training resources that we have for all the languages, here you can see that at the left of the scale, we have few instances with a few language pairs with almost or more than 1 billion training examples. But once you go down this graph, this curve, you have by the 200th language, we merely have around 10K parallel synthesis. This is not enough to be able to train a decent translation system. And what about the more than 6,000 languages that are in the world? So if we want to really make a dent and really connect people across languages, we need to solve the problem of low resource translation. And low resource is beyond just training data. You know, the challenge of translation comes from language similarity. Translating between languages like English and Spanish is easier, or English and Portuguese is much easier than translating between languages like if you take English and Hindi, or English and Nepali. Also the domain. If your target is to translate social media posts or news articles, it's really different if you train with open source Ubuntu manuals or IT manuals in general. And the third challenge that we have is that evaluation it's really challenging because we don't have curated data sets for all of these languages. So this impedes us from knowing what works in realistic low resource scenarios. And this is one of the things that my team and I first tackled. So we created the Flores dataset, the Nepali English and Sinhala English, and new languages are coming. And the idea here is to create a really highly curated, diverse dataset that allows researchers to measure the progress in this area. Now, creating a dataset seems like a no-brainer. It's relatively simple, right? Well, think again. When you are looking at low-resource scenarios, this is a very challenging task. First of all, sampling. We sampled a very diverse set of documents from education, religion, sports. But moreover, once we go into translation, usually that's the end of it. If we talk about high resource translation, you know, the human annotation pipelines are very highly developed and produce very high quality translations. But once you go into low resource, this is not the case. So we need to implement several rounds of automatic checks to verify that the translations were actually of a reasonable quality. And then we moved into human checks where another human, actually went and evaluated the translation to see if the translations were of the quality we expected. Finally, we created and curated the data sets. Once we have these data sets, we can actually start looking at what help us to improve the quality in low resource scenarios. So one of the techniques that works really well, we discovered, is multilingual training. This is leveraging resources from a higher resource language and using transfer to improve the training of a lower resource language. In this case, for example, Belarusian and Ukrainian. Ukrainian has more resources than Belarusian, and both languages are used by populations that are closely related geographically. So there's similarity of topics that they're discussing. Now, this nowadays scientists are exploring the limit, really pushing the limits of multilingual training and bringing models that can translate hundreds of languages, like is the example of the most recent G# paper from Google. Another technique that we found really useful is back translation. For those who are not familiar with this technique, this exploits semi-supervised learning, in which you start from a really small amount of curated data and you train this intermediate model. And then you use that intermediate model to translate large amounts of unlabeled data. In this case, we learned to translate from German into English. Once we did that step, we can really use that data, reverse it, and use it to translate, to train an English-German model. And this is really pushing the state of the art for resource language. This is one of the techniques that are winning competitions in WMT or other international competitions. Now, what's the problem of using this technique as it is for low resource is that this intermediate model is actually very bad quality. It's very noisy. So we really need to retrain it or do it this process iteratively. So the intermediate model gets better and better every time. And the last thing that we tried is using weak supervision. So we leverage what we call language agnostic representations. That is, an encoder maps sentences like the dog is brown, el perro es café, into a very similar multidimensional space. Their embeddings are really close to each other. And what this gives is that we can really identify sentences that lie in this space simply. But and use this to mine sentences from, say, Wikipedia, from Common Crawl. This allows us to identify which sentences map to each other and build collections of corpora that encompass, say, very large and very low resource languages. And we publish this corpora like Wikimetrics and CCMatrix. So how does this work? If we take a look at the results on the Flores dataset for Nepali English, we see that supervised, it's really giving a low blue score. And blue is a measure that allows us to identify how well a translation overlaps with what a human would translate. So just to give you an idea, for languages like Spanish, English, we see higher blue scores in the order of 30s and 40s, depending on the data set. Now, supervised learning is clearly lagging behind. Having weekly supervised data help us to increase the blue scores, but really semi-supervised learning really shines here. The first iteration gives us a huge boost in performance, and then the second iteration gives us an additional huge boost in performance. Once we add the multilingual part, you can see that leveraging supervision from another language really helps here, from the supervised to the semi-supervised in several iterations. Now, to give an example, how does this look like? If you take, I don't know if this is completely readable, but I can read it fairly quickly here. This allows us to go from translations. When we bring this to production, the translations go from something that was useful, in this case, from Nepali to English, in a lot of Keila family. There are normal meal, chamal, and vegetables. You can see in this example, the third row, in the second column, that this is fairly, it's understandable, but it has a lot of OOV words. And then once we move to the next one, we can see that the OOV words in many Kerala families, a common meal is rice and vegetables. So we can see that OOVs are out, and the fluency improves significantly. And this really allowed us to ship new language, new translation for many, many low resource languages like Cambodian, Burmese, etc. And that's it from my side. Thank you, folks.
Thank you. Very interesting. So I remind you all that you can post your questions and vote for them in the link pinned in the chat, Menti. So there's one question for you, Francisco. We'll ask one question after each speaker, and then we'll leave a couple for the rest. The question is research becoming so hard and costly that only bigger major labs and companies like Facebook will be able to do state-of-the-art useful progress?
I think this is the other way around. I think at least our approach at Facebook is we really want to, we know that we cannot do research alone, and any really big problem, we really need help from the community. So our approach is the other way around. We use our resources to create a framework so others can do research in these important problems. This is what we did for low resource, and we keep pushing this idea. We keep doing also this with PyTorch and FAIRSEEK, and other tools that we make publicly available, so others can really push the state of the art as well. We know that we cannot do this ourselves.
Okay, perfect. Yeah, that seems correlated with the direction of, yeah. Okay, so maybe now Aisha and Mariama, if you're ready, I already introduced you, but just briefly, they both did their African Master in Machine Intelligence Master. I think that you would both the first generation, if I'm not wrong. And I personally know Mariama. We had an internship together, so very excited. I hope this can foster interactions between the Latin American community and the African community.
Can we start?
Aisha, are you seeing the screen? The slides?
No. Yes.
Aisha?
Yeah. Okay.
It's okay.
Yeah.
Okay.
No, you shift it again.
But Mariama, you either have to share as an application instead of your whole screen, or you can, like right now we can see it, but probably you cannot see us, right?
We can see this.
We can see it, but you probably cannot. You can talk like to see us, I guess.
Okay.
Yeah, that's so shit.
Okay, thanks everyone. You can start, yeah?
Yeah.
All right.
So Mariama, just 1 second. Mariama, alternatively, you have to unshare your screen and then share it again. And when it asks you share the whole screen or share an application, just share the application.
Oh, okay. So, okay, application windows. Okay. Okay. Okay.
Perfect.
All right, so I'm going to start first. Hi everyone, we are so excited to be here. Thanks for inviting us. So my name is Aisha Alaagib, and so Mariama and we are going to present some of our work. But before that, we are going to introduce first our institute. So Mariama, can you click on present? Yes, fine. Yeah, it's fine. All right. So Mariama and I were the first cohort for African Master in Machine Intelligence AMMI program in Kigali, Rwanda. So African Master of Machine Intelligence is 1 year master program. Is offered in partnership with Facebook and Google. Was launched in Kigali in October 2018, and so it's directed by Mustafa Sise, which is head of Google AI Accra. Okay, so we were like 29 students, so from different African countries, from different backgrounds, mathematics, statistics, computer science, physics, engineering. And so we were all like, most of the students didn't have any background in machine intelligence, so we started there. And so now we just give you some overview about our environment. So AMMI program is like now this year in 2 centers, one in Kigali and one in Accra here in Ghana. So the students are coming from 28 different countries this year, and we have 79 students selected from 7,000 applications. So the current cohorts, we have like 34 students in Rwanda and 43 students here in 34 students in Ghana and 43 students here in Rwanda. So 32% females. So the program is very intensive, and the lecturers are coming from all the world, from Facebook, Google, also from different universities. So the percentage of the accepted rate is 60%, and 35% is female. So from our cohorts, like we graduate, the graduation rate was 91%. and all of us from African countries. Okay, after finishing the program, most of the students have went for residency program and internship in Facebook, DeepMind, Hugging Face, Mila, Google AI, Qualcomm, Vector Institute, and Evado. And Mariama went to Facebook, and me, I'm from the student who went to Vector Institute. So this is like just a bit introduction about our program. Wanted to share it with you. So now I'm going to share my experience from AMMI and after AMMI. So during AMMI, I have been working in different projects and also participated in different challenges. I started my journey by doing some challenge. So first challenge that I have went, it was the cassava disease classification, where group working in cassava disease classification. It was dataset from African countries, and it was Kage computations. It was in CVBR 2019. Also, another challenge we participate in, it was computer vision for crop disease. It was in ICLR this year, and also won the first. I won the first place for African learning. Okay, so after finishing from AMMI, I went to Vector Institute. I have been working in multimodal learning. So, introduction, multimodal representation learning aims to learn task-specific representation from two input modalities or more than two at the same time. So the name modalities is referred to speech, vision, text, medical, different modalities we have. So now there's a lot of challenge have been introduced in multimodal learning. So there's a lot of research it has been done on vision and text. So the challenge in multimodal learning is like start by fusion. Mariama. So yeah, so one of the challenges in multimodal learning is the alignment. So the alignment is like inferred feature correspond between modalities. It generally involves like similarity score for guiding the training procedure, but it does not aim to combine both modalities into adjoint representations. Another challenge in multimodal learning is fusion. So the fusion aims to learn the joint representation for different modality by combining several input modality to predict an outcome. We have like, it can be late fusion or as example, which is like combine the modalities after proceeding or getting the representations for the text and the image. And also it can be early fusion, which is like combine the representation from the beginning before the passing to the classifier. Also, there's another challenge with the translation where I have been working. So translation is like try to translate one modality to another modality. So let's say it's like going from image to text or from text to image. So the model we have been working on, it was like try to find a model or find an idea. How can we learn joint representation in the same times? So learning different representation is a problem because the one problem is like, how can you learn disentangled representations? So we have proposed one idea, which is like multimodal learning using memory share. So the idea is like get the representation for different modalities and now pass it to the memory. So the idea of the memory is like having different blocks inside the memories. And now each block, it should have just one representation for each object. So one of the challenge is like, how can each block have disentangled representation from the other block? And this will be like, how can we have a disentanglement block inside the memories? And also, so how can we sample from the memory to get what we want? For example, if I have image and I want to get text from the image, so I will get the representation I will sample from the memory and now try to predict my text. Another project I have been working here with Mustafa Siste, which is related to adversarial example. So there's a lot of work has been done on self-supervised learning, but no one has introduced the idea of self-supervised adversarial example. So the proposed first idea approach to generate black box adversarial example in a completely unsupervised way and demonstrate their transferability, and also try to attack different models and perform different tasks such as classification and segmentation. We are also trying to generate universal self-supervised adversarial repetition and demonstrate their transferability. So in this work, we're trying to focus just on self-supervised models. So one of some of the models that we have used, it is RootNet and also clustering. So this project is still going on, and also I have been working in another project. Because of the time, I can't introduce it. So Mariama will continue.
Okay, so as Aisha said, I'm also part of the first cohort at the AMMI program. So at the end of the AMMI program, I went to Facebook for a 4-month internship. There I was working on a project about knowledge composition from dense sentence vectors. We know that we have lots of libraries that are computing sentence embeddings, but the goal of this project was, can we compose those representation and get a meaningful representations? So we use 2 data sets, Wikisplit and WebSplit. Both data sets have like complex sentences split it into multiple sample sentences from 2 to maybe 7, I think, on WebSplit, but on Wikisplit we only have complex sentence split into 2 sentences. So we use both data sets, but we only choose sentences that was split into 2 simple sentences. So the goal here was when we embed the 2 simple sentences and we pass it to the model, the vector output of the model, will it be as close as to the embedding of the true complex sentences. So we use 2 libraries called Laser and Roberta from Facebook, and to embed our input sentences, and also we use a multi-layer perceptron to compute the compositional embedding vectors. To evaluate the model, our compositional model, we use 3 evaluation methods. It's one where we have the true complex sentence embedding, and we randomly choose 9 other complex sentences that we embed also using Roberta or Laser. And now we are going to evaluate how close is the model, the output to the true sentence or the 9 randomly sampled sentences. We also use paraphrase ranking, where the true complex sentence is replaced by its paraphrase. We know that in WebSplit we have paraphrases. So for this evaluation, it's in paraphrase ranking, we only use WebSplit, because in Wikisplit we don't have paraphrase and sentence in Wikisplit are not that close as in WebSplit. So in WebSplit there is lots of overlapping between sentences. So we also use a question answering method to evaluate how much knowledge was captured in the output of our model. So the input of the question answering is a closed question, which is obtained by masking a name entity in the sentence, and the output of our compositional model. So the question answering take as input a closed sentence and the embedding vectors of the full sentence before we mask the sentences. And now the model is going to, the output of the model should be the masked words. So here are the 2 evaluations, and the results are given in these 2 tables. So we also tried the addition multiplication, which was proposed before this work, and we see that our MLP model was performing better than the addition and multiplication models. So when I left Facebook, I went to Hugging Face for 6 months also. The first project that I worked there was about text generation, on poetry generation, and I did it using GPT-2 large, which is a large transformer-based model. And here it was just like how the model, like I didn't train it from scratch. I used the Hugging Face library just to pre-train the GPT-2 model to generate poetry. So after this project, I also worked on the Nlp Library, which is a library to easily share data sets and some NLP metrics. Maybe it's going to be extended for vision data sets and other data sets, but for now it's only focused on NLP data sets. So after this one, I also worked on the Blender Board project. It's not released yet, So this Blender board is an open domain chatbot from Facebook released recently. So it's a simple transformer encoder decoder model and has 3 model sizes, like a 90 million parameters, a 3 billion parameters, and a 9 billion parameters. So I implemented the 2 first models, but wasn't able to release it yet. Maybe it's gonna release in the coming weeks. So yes, that's all from our side.
Thank you. Very interesting. So I think it's
from our side if you have.
Yes. So I think both that you presented are really interesting. Both the technical aspects and it's very inspiring to see your trajectories. So I would like to ask 2 questions that you can feel free to answer whoever of the 2 wants. So one is that is asked by the audience. Remember that in the Menti link you can vote for the questions, is related to alignment. I think this applies both for natural language and for multimodal. And the question is, how relevant is word alignment for non-lexical words or concepts like prepositions, now that statistical machine translation and others are replaced by deep learning approaches? Yeah, how relevant is word alignment? And the second question is more related to your experience. So Africa has really done a great job at putting themselves in the global map of AI, both through the workshops at NeurIPS and the major conferences, and also through your masters. For context for everyone, I don't think there's any masters like that in all of Latin America. They really get some of the best speakers from the world, and that really pushed all of the cohort. Like as Aisha was telling us, they really go to some of the best places in the world to do research. So if you have any suggestions or any for Latin America, that would be great. So please answer those 2 questions.
Sorry, I had a problem hearing the first question. Can you repeat it again? Sorry.
Yeah, the first question is related to word alignment, and it is how relevant is word alignment for non-lexical concepts such as prepositions or other parts of text which are non-lexical. Now that statistical machine translation and many other tasks have been replaced or are being used using deep learning, how relevant is word alignment there? Either for multimodal, you talked about alignment, or for just purely language tasks.
All right. So I don't know if the question is related to the alignment in multimodal learning. So the alignment is like one of the challenges in multimodal learning, like trying now to find how far this representation from the other representation. So let's say you have a text and you have an image, and now you get the 2 representations. So there's the early alignment and also I think late alignment. So try to find finding the score between the 2 representations and see how far, like let's say I have an image which has like a ball or object like a chair, and now we are asking question about some of these objects. So the alignment is to find the score, like each element is related to which object exactly. So I hope I have answered the question.
Yeah.
Can I contribute a little bit to this answer?
Yeah, sure.
Yes, of course.
So
yes,
yeah, so I would say that, even though we're using machine translation, there is a lot of work into making the reading part most efficient for a scale like at Facebook. And there are techniques that still use lexical word alignment to really filter the amount of words that we're using. So it's a kind of pre-filtering step. You reduce the space of your decoding space by basically selecting likely translations in the output, and this helps you to speed it up. So there's still use for this lexical word-to-word alignments.
Okay, thank you. So Mariama and Aisha, I don't know if you could, Luis Leal, who seems to be a professor in one of the first masters in data science in Central America, is asking a question related to the one I asked, which is, how did your country manage to get support for the master's program from the big companies and labs, and or any other suggestion you have for the Latin American community?
Yeah, so the master, it was introduced by Mustafa Sise. So Mustafa Sise is a head of AI, Google AI in Accra, Ghana. So he was working in Google and Facebook, so, and with another people from Africa. So they tried it, like they went and out of countries, and they came back to bring all their experience to share it here in Africa. So I think this is all is their work and what they have done to do this for us. So it's like now the fund is coming from Google and Facebook, but now the lecturer is like all of them from different worlds. It's like volunteers. So it's like everyone will be excited to come and visit our countries, and now we'll offer you everything, and I'll try to share some information with us and CC students. Yeah.
Thank you, Mariama. Anything you want to compliment with?
Yeah, like what Aisha said is how we can contribute for the Latin Americans. So I don't really know, but I think like the main goal of this master was to grow AI in Africa, because like if you look at the few years ago, there is very few Black people in big conferences. So right now we are trying to do our best to contribute in big conferences and also going in the big companies like Facebook and Google. So that was the main idea of this program. So maybe how we can contribute, because the goal is not to teach us AI and we're still in Africa. Yeah, we can grow AI in Africa, but if being anywhere in the world. So we can be in Mexico helping them set up a program like this one or better or something like that. So yeah, like I think.
Yeah.
Yes.
Can I add something?
Yeah, sure, for sure.
Yeah. So also it's like one of the ideas, like now getting good students and now working on different projects from. I believe that we have a lot of data sets, and now we are here in Africa, but we are participating in different projects in different countries in Europe, America, like everywhere. So the idea is like, how can we connect AI in all the world? So, and how can we use in our resources here in Africa and other countries?
Great. Maybe we can talk about, a little bit more about that in the discussion after.
Sure.
So let me introduce now Pablo Duboue. He has already participated in RIA with a workshop, which apparently went really well. He's from Argentina, where he did his undergrad in computer science. He obtained his PhD from Columbia University in computer science too. And then later he joined the IBM Research Deep QA group, which was responsible for developing Watson. I don't know if you were directly involved in Watson or just a part of the team. And now he's the founder of Textualization software and splits his times between teaching, doing research, and contributing to free software projects. So Pablo, please.
All right. Thank you so much.
You're muted, I think.
Hello, can you hear me now? Yeah. Okay. So thank you very much. I'm very excited to share a little change of pace, but it's quite in the direction also of Guzman's talk. So let me share my screen. And to answer your question, yes, I was actually part of the question answering team before the Watson project. Yeah, so I did started, we were only 4 people when it started, and I was part of those 4. So the talk I'm giving today is quite targeting the students and practitioners in that among the attendees that are considering doing a solution, practical solution using natural language processing. And what I'm trying to ask is whether we have a last mile problem. Yeah. And I've been doing natural language processing for 22 years. So in that sense, you can think of this as the old man yelling at the Google Cloud talk. Yes. And what I'm offering you is a metaphor. And it's a metaphor that can help you understand things, and it can help you communicate with people outside the technical community. And the metaphor is as follows. There are certain problems in natural language processing today that from the problem statement to the solution is as simple as taking an airplane. Yes, you just fly through the air and arrive to a solution. However, if for other problems, you may still take the airplane, but to get from that airport to your final destination, to your solution, you will have to wade through the jungle. And it's not going to be easy, and it's not going to be pretty. And this is something that you need to keep in mind to communicate and to conceptualize your solutions. And then, well, the question is, who builds the airports? Who owns the planes? Back in the ACL 2002 in Philadelphia, I do remember, I may be misquoting, but from my own memory, in his keynotes speech, Peter Norvig, that at that time had just joined Google, he mentioned something on the lines of, I felt I was a particle physicist and Google owned the only synchrotron. Yeah, and it was explaining why he went to Google. So these are the people who build the airports, these are the people who own the planes. The rest of us, we have to work. And there is a very long journey from airport to destination. You may have seen these headlines on technical media, that there is all this great technology coming around, and people tried to their own problems, and it didn't work. Yes, and they felt that they were shortchanged. Why? Because they were hearing all this exciting news that a new airport exists, and instead, they when they tried to do it, they realized that they were still very far from where they wanted to be. So what does it mean, really? It's like either you stay near the airport, yes, so you work for a problem that is similar to other problems that have been solved, but it will cost you. It will cost you time and effort. And what are the airports? So a big thing that we need to make sure we communicate clearly and we understand within the field is which problems we have great technology and solutions. A good way to see where are the airports is to look at the benchmarks and the data sets that are used for that. For example, the GLUE benchmark from one another 2018 that has inference, classification, question answering, sentiment analysis, paraphrasing. We have a data set for name entity recognition. You have machine translation data set. This really goes in Guzman's talk about low resource languages. And of course, the airlines work the same way as an airline, right? You go from where there is a lot of traffic. So the pre-trained models happen for where there is a lot of data. So these are our conceptual airlines. So I'm saying at the beginning that I'm yelling at the cloud, but in reality, I don't think this is a problem, yes? Moreover, if you think, for example, when you have train stops in the middle of the Midwest, they spawn whole cities, yes? It's the same thing. When a new technology becomes available and you have these new resources that get released, then a lot of peripheral problems near that get solved, yes? So, and we are adding new airports all the time. The problem for me is just that it's a reality we need to acknowledge and embrace. And right now, I feel that in the practitioners community, there is this pretense that we are living at the airport all the time. And that's definitely not the case. Why? Because, again, building on Guzman's talk, many problems don't have much data. One of my first papers was on disambiguating proteins, genes, and RNA in text, yes? And we scan 1,300 articles, and we only find 9,000 instances for training the classifier. This is a very difficult problem, right? In genetics, you use the same word to refer to a protein and a gene. And you need to know that genes clone things and proteins bind things, and that's how you can distinguish them. And medical domain is known to have very few available data, but a lot of human expertise. And we would agree that in 2020, medical domain is a domain we don't want to pass on. Something that many of you may be thinking, right? Well, what about transfer learning? And transfer learning is great. I have used it in consulting engagements and a paper I published last year. But to me, it's similar to taking a taxi from the airport. It only works if your problem is near the airport. So how slow is the ride if you want to go far? I love this figure from the Watson project because it really highlights the amount of effort that natural language processing projects take. So this curve that you see here, the baseline curve, is where we were with the work from the question answering team at TJ Watson that had years of progress, and it was a very, very poor performance compared to what we achieved later. Between each of these lines, there is months and months of work by teams of people. And something that is not shown in this line is that the team also keep increasing. As the project gets more successful, we start with 4 people and we end up about 30. Therefore, but the lines get very close too. The difference between having a system that performs at 80% and one that performs at 95 is not a little bit more work, it's significantly more work. And the issue is that many problems that we want to solve to deploy products in the market require that type of effort. And where that effort goes. So to me, there is a tension between engineering and research. In recent years, I have reviewed for many big conferences, and what I'm seeing is that it's very tough to publish outside deep learning these days. In that sense, it feels that for many problems, we are just waiting for Google or Facebook to build us an airport. Yes. So that's maybe okay for research, but if you actually want to build things, what do? For me, my personal take on the problem is that you add domain knowledge. You look into linguistics, you add features, yes. These things don't solve the deeper AI question, but it solves the human problems of today. And putting my effort on this concept, I've written a whole book on feature engineering that just came out last June on Cambridge University Press, and it includes 10,000 lines of Python and 5 case studies that I'm releasing open source. And it has a whole case study on NLP data where I showcase problem-specific tokenization. And of course, deep learning has realized the value of problem-specific tokenization, and you have things like byte-pairs encodings and things like that. But again, if you have little data and understand the problem and understand what you're trying to do, you're better off writing a few lines of code and writing a problem-specific tokenizer. So my takeaway for you is you need to handle the expectations of your users and customers. And I'm giving you this metaphor. Yes, so you tell them, well, yes, this problem you have is great. And I'm sure you have seen these YouTube videos that show that with this fancy new model, everything should be solved in natural language processing. But you still live in the middle of Everglades. Yes, that airport nearby, yes, is maybe nearby. But it really doesn't change your time to market, doesn't change the time you take to go to Miami. Yes, you still have to get out of the Everglades, and the Everglades are full of alligators. To conclude, unrelated to this, last year I presented a paper in Clay in Panama City. That paper is maybe you may have not seen it because it's not in an NLP conference. But I took 15 years of Congress transcripts of Costa Rica and Argentina, and I evaluated BERT adapted from Wikipedia versus the Argentinian dialect and the Costa Rican dialect. And the question was, well, which one needs more fine-tuning? And all the paper, all the source code, and all the data is available in the link there. And I invite you to take a look at it. Thank you very much, and I look forward for questions and a lively discussion. This is a fantastic panel. I also want to say I have a joint venture with a Cameroonian Canadian from Ottawa for many years, and they make a fantastic business partner. So I highly recommend it. Very good people. Okay, thank you very much.
Thank you, Pablo. Very interesting and complimentary presentation, I think. So one question from the audience is, could you, and related to what you presented, is could you give us some advice to work in NLP when we do not have enough computational power? It seems like working outside of those airports seems to be like a good place to do that, but do you have some advice for people here?
So back when I started, we didn't even have machetes because it was even at the time we were doing more rule-based systems instead of machine learning. That stuff is very laborious. So if you're going to take small data, do features, annotate them, in the metaphor, this will be equivalent to taking a boat. Yeah. The good part about that type of things is that we have a much better understanding about the type of mistakes they make. Yes. So you're not going to publish any paper saying I took 9,000 sentences and I annotate them by hand and I build this model on top of them, right? It's just not state-of-the-art research. But that type of thing, you can improve it stepwise to get to something that solves things. And for that, what you need is a lot of hand labor. And hand labor is much affordable in Latin America. So that's a way of trading things from my perspective. But of course, I'm super interested in hearing the positions from. It's been 10 years. I left corporate research, and I've been focusing on helping startups with my consulting. So it's a very, very different type of resources and people I interact with. Yeah, I imagine you've seen the trends and the evolution of the field. So and there's a few questions, but maybe we'll get to them after the last presentation. So professor at Cornell, researches in the intersection of natural language processing, deep learning, and structure prediction with applications in text generation and efficient inference. He's a research led at Hugging Face and has developed several other widely used NLP open source projects. He's on the board of ICLR, and he manages Miniconf, a tool used for hosting virtual conferences. His research has received several paper and demo awards at major NLP visualization and hardware conferences, an NSF Career Award, and several industry faculty awards. He was the general chair of ICLR this year. And for me, it's a personal honor to have you here, Aisha, as you were my professor in the Advanced NLP class at Harvard. So thank you very much for being here. And the floor is yours. I think you're muted right now.
Thanks so much, Andres. Very nice to be here. And getting used to virtual teaching. So I have a teaching environment set up. So I'm going to just present from here. So today I'm going to talk about controllable text generation. Just to introduce myself, I'm a professor at Cornell Tech in New York City, and I work at Hugging Face with Mariama. I've worked on automatic text summarization. I've worked on compressing translation models to run on things like mobile devices. And I've worked on some kind of interesting uses of neural networks, such as OCR for handwritten mathematics. And I think my talk today will fit closely into the talks that people have presented so far. So a lot of the work I do is in deep learning. I also develop a lot of open source projects. A lot of these projects are kind of applications of methods that come out of big labs, but also try to make it plausible for people to utilize these tools. So just for everyone here, a couple projects I've been working on these days. So one is a kind of learning toolkit for people who want to understand the process underlying Torch and deep learning libraries. It's called Mini-Torch, and you can find it online. It's a series of kind of 5 do-it-yourself exercises to learn about how things work under the hood in Torch, and it's a fun project. I'm teaching with it this semester. Another project is called the Annotated Transformer. It's a kind of learning library about how transformers work for those trying to understand what's going on when people talk about BERT or other models in modern natural language processing. And then finally, a project I've worked on kind of with Mariama is a project for viewing NLP datasets, NLP Viewer. And we have a collection of, Mariama would know the number now, but I think it's like 150 different datasets in NLP that you can kind of see in real time online. So today I want to talk a little bit about some of the challenges we face in the current world of natural language processing. As everyone's been talking about, a lot of the models that we utilize now look, they have this kind of black box form where we have a single learned model, often given to us by a large corporation that we then utilize to do prediction. And the main mode that we use these models is that we feed them some input and they give us some output, and we either like it or we don't. And it's not clear what to do if things go wrong, or if the model is biased, or if you want to incorporate some other sorts of information into this setting. So a project I worked on for a while was trying to understand what these black boxes do. And in particular, we would try to look into the model and look into the input. And one of these projects on the right here, LSTM-Viz, tried to understand the particular kind of activations of the neural network over time and try to puzzle out or figure out what sort of correlations there might be in that setting. But unfortunately, the problem with this is that while it can sometimes give you affirmative confirmation of something that you might be looking for, it doesn't really give you a good way of understanding how decisions were made. And there's a lot of decisions that you really can't analyze at all with this sort of method. So recently, I've been thinking about kind of this problem we refer to as collaborative natural language inference. And really the goal here is to try to understand how we might build models that explicitly take into account the fact that we might want to modify or try to understand specific decisions in the model itself. So instead of trying to post hoc go back and understand what a model does, we're going to redesign the actual model we train to try to build in aspects that we want to try to understand. So we're going to do this with a kind of methodology that looks like a hook, where we take a very strong model to begin with, and we try to modify it with specific aspects that we'd like to understand. And unfortunately, I don't have enough time to really go into details, but I want to give you a kind of case study of where we applied this sort of method and what it can allow us to do with systems that we have. So the case study I want to talk about is a problem that is dear to my heart, which is learning to talk about data. This area is often referred to as natural language generation. We're going to be given some sort of structured data set, and we'd like to produce some output text that roughly describes what that data set tells us. And there's a lot of different data sets here, and they all have a lot of different properties. I'll go through a couple of them. This one here takes an example of a Wikipedia fact box and uses it to try to produce a description of a person. So if you feed something like this into a neural network, you'll get an output like this, describing the first line of this person's Wikipedia bio. But every once in a while, when you put in this input, you get an output that instead looks something like this. Frederick Parker Rhodes was in English mycology and plant pathology mathematics at the University of UK. So this sort of output is partially fluent, but kind of nonsensical. And it uses data that it was given, but it uses it in non-standard and problematic ways. So we'd like to build a system that can explicitly try to prevent a system from ever really being able to do this. And we're going to kind of lose some of the accuracy of this, lose some of the kind of end-to-end nature, how can I put this? Lose some of the automatic nature of the system, but gain back the ability to check that the output was correct. So let's look at a particular example. So in this particular paper, we built a model that utilizes a form of classic probabilistic clustering, particularly for time series. In particular, we use a model known as a hidden Semi-Markov model. And the goal of this model is that it tries to produce a high-level discrete cluster for every phrase in the documents it's given. And it's going to do this in a latent way. So it's not going to be given these clusters. It's going to try to learn them as the model itself. So in particular, we're going to create a hybrid model. This model consists of a state-of-the-art neural network pre-trained model intersected with one of these hidden Semi-Markov model units. And a lot of the paper is about showing how you can combine these two systems and showing a technical methodology that allows you to get the benefits both of learning this sort of clustering model, whereas also utilizing a model that can give you the benefits of having a pure neural network-based system. And the punchline here is that by learning both of these together, it's accurate to pull out templates that represent exactly what it is that the model is trying to talk about. So let's look at this example. So here we have a smaller data set, but a related one, where we're trying to describe the properties of a restaurant. You can think of this as kind of an automatic Yelp-style output system. It's kind of given properties of the restaurant itself, and it wants to describe the text. But our model, before actually producing any text, is going to produce a template that it thinks would be useful for this set of tables. And so it takes one of these templates, which allows it some flexibility, but less flexibility than just generating arbitrary output words. It then produces an output that utilizes the data, but is guaranteed to satisfy the template. This gives us a way to check that at least the factual information that we use in our output is generated correctly, while not losing any of the benefits of training a neural model for this sort of problem. In practice, what this means is that when we do text generation, we get a certificate telling us what properties the model was trying to use in its output. So in this example here, where it's taking a text box from Wikipedia, we get a guarantee in the green color that it's going to utilize the full name of the person it's given. In the yellow color, we get a nickname for that person. Blue is what country they're from, and pink is the year they were born. Simultaneously, we are able to change templates to restructure the output of the sentence directly. So we're not completely reliant on the neural network just generating what it wants to generate. We can actually tell it to generate different syntactic patterns or produce different outputs of the sentence itself. So where do we go from here? So I'm very interested in questions of how we generate from more complex data structures and produce longer outputs. So in this data set, we have a full kind of table representing the statistics in a sporting event. And we're interested in producing articles that represent everything that was done in that game itself. Here we have a much richer set of different entities than we had in the simplistic Wikipedia example. And we also have questions of discourse structure, questions of reference, and questions of kind of matching sentences throughout the whole document. What we hope to do is produce systems that allow us to apply these sort of controllable generation approaches to full documents, to have similar kind of explicit clusters representing discourse properties, representing references in the document itself, and representing aggregations over the source data. We're also working with experts in visualization to try to make it possible to build systems that will allow humans to interact and change what outputs do and produce different properties in the data structure itself. So for instance, being able to flip certain entities or change the syntactic structure simply by changing one of these clusters. So in conclusion, I think precision control are a significant issue for these sort of neural generation systems. I'm very interested in improvements in the models for probabilistic control, in particular in the intersection of probabilistic modeling and deep learning and efficiency. So we're very interested in building kind of tools that make it as easy to build fast probabilistic deep networks as it is to build, say, a simple convolutional neural network. And building these tools, I think, will make it easier to integrate these hooks into realistic models in the real world. Okay, thank you very much.
Thank you, Sasha. I think this connected well with the conversation that was happening and combined deep learning with other things like structure prediction and feature engineering and others. So before moving to the general discussion, let me just ask you a question that was the most voted by the audience here, which is there a gap between training NLP corpora, which uses well-formed language, and then transferring that to real life where language is different, there's slang, there's misspellings, there's regionalism. Is there a gap to be handled there? How could you handle that phenomenon?
I can provide an answer to that. This is a problem that we face every day, especially at Facebook, right? Because the input that people produce it's very different than the news sets that standardly we have curated data for. So people introduce a lot of syllogism, new terms. They introduce a lot of abbreviations, misspellings, non-grammatical sentences. Sorry. So this is obviously something that we care about, and we actively look at. We have internal data sets in which we measure performance. So we cannot always say that, oh, just because something worked for WMT, this technique is necessarily going to work in our internal data sets. we have to test that, right? And that's part of the research to production process, in which we actually test with cases in real production usages. I don't know if that answered the question.
Yes, I think so. So let's move into the general discussion, and let me start with a question that maybe Sasha could start answering from his Hugging Face standpoint, but it's a question for everyone and all of his research, which is there's clearly a trend towards scaling computational power, size of data sets, all of that. Do you think, but you also have all of this experience from the structure prediction and other types of kind of like probabilistic modeling. Do you think like NLP can approach human capabilities mostly with scaling, as suggested by GPT-3, which Sutton has argued, or do we still kind of like radical innovative ideas that haven't appeared? Are those still needed? Maybe Sasha can start since he didn't get a question, but it's for anyone also can jump in if you want.
Sure. I have no idea. I've been really surprised at how well scaling has worked. I guess I just don't try to make predictions. I think there's a strong argument that there are a lot of things in text that are not written down, a lot of things in thought and reasoning that can't simply be extracted from text, but I'm not sure anyone really knows what to make of how much text is in GPT-3. Like the scale of the amount of utterances these models see is I think beyond what I really understand in terms of how much you can get out of that. So yeah, I don't actually know.
I'm reading a book that got recommended on NeurIPS, called it Beyond 0 and 1, which is a very, very funky book about, thesis of the book is we should make AIs that can take LSD. Yeah. And one of the things it says is consciousness is something that the author considers important for evaluating an AI. If the AI doesn't have a concept of self, then how come it's going to be actually intelligent? Yeah. And because the person is coming more from cognitive science and philosophy. I said, all the AI scientists I know, the book says, don't care about this question. Yes, they care about making some things work, etc. So to me, I found myself very represented on that. It's like, are we going to get this level of understanding? I'm working on solving some very specific thing. So I feel if the people, the community is interested on betting these type of things are a little different. There is the book Architects of AI that interviews Ferrucci and people established in the field and asks them, when are we going to get AGI? And the average is 70 years in the future. In 70 years in the future, I'm going to be dead. So, you know, it's to me, all these questions are going to be settled way after I'm 6 feet under. So it's, I don't find those questions something that can help me drive my work. But there are fun, and I really appreciate the people who spend time thinking about
it. Anybody wants to compliment? If not, what about in the next few years? So that was a little bit like far-fetched, like human level capabilities, and Pablo was talking about consciousness and other things like that, which I agree. I would like to see more, and I think I started to see them in things like intrinsic motivation. There's a wake-sleep algorithm has reappeared in some models, but I agree that those are relevant and interesting. In the neuroscience-inspired AI panel, there was a similar question asked, and Felix Hill, who's a researcher at DeepMind, was saying that what he thinks is one of the things he thinks is lacking is not necessarily like algorithmic improvements, but richer data sets. Like the type of data received by a GPT-3 is very different than the type of data received by a human. But anyway, so in the next few years, from your experience, what things could we expect like in the next year, in the next 2 years? Will we have like impressive unsupervised both that combines like both vision and language with the recent success of both, that will be able to generate like movies? Or do you have any take on that, or any other trends that might happen that we could expect to see in maybe?
So I can tell you a little bit more. It's slightly different, but it's still very relevant. So we have these models that are outputting very human-like output. The problem is that we are not scratching enough the surface of what is the effect of these outputs in people, right? So all of this responsible AI area, it's just something that is very nascent, and I think I want to bet that this is going to be something that the community is going to look into more seriously. I can tell you some examples of things that has happened with generation in our site. Sometimes we've generated translations that introduce a profanity, right? And call a mandatory, a precedent, something really bad. And that is a problem, right? And this is not something that our general way of evaluating AI or evaluating outputs takes into account, right? Because these are very rare events, but they cause a lot of damage and trust in the output of systems and of models. So I would bet that the responsible AI is going to be an area that many companies and institutions are going to start looking into more deeply.
Okay, yeah. Anybody wants to complement that? Or so let me take one more question from the audience, and then maybe I can ask if there's any final comment or something. What are the most important steps or more valuables to obtain good results related to text pre-processing? Like, is using a good tokenization method pretty important? Stemming? Any comment on that?
I guess that will be more of feature engineering, right? I do find that super important, and it's one of my biggest gripes is that many times they give you models, but they don't give you the tokenizer they use. And the other aspect I will mention is encodings. It's a very, very common problem to have source data in different encodings, particularly working with language with accents. So these issues affect performance much more than we like to believe. If you have a system that splits things into accents and they consider them as different tokens, that's a big issue. I'm pretty happy with the new tokenizers that come with BERT. That's pretty good. But much more openness from part of the companies is needed there, because there's a lot of engineering that goes into a well tokenizer, and that's a business advantage. So I realize that they're happy sharing the models, but the tokenizer is built by a different area in a way, and it wouldn't be that easy to release. But
actually, maybe I misunderstand. I feel like this was a problem that used to be pretty widespread, but is one of the things that really got solved nicely by things like BERT. I mean, you don't really have to worry about stemming or any sort of morphological pre-processing anymore. That's all kind of gone, which I think is quite nice.
If you try to combine different models released by different people, they may use a different idea of what a token is.
Mm-hmm. I see. This is something that is solved by Hugging Face these days, but I think most models come with some sort of tokenizer, or equivalently PyTorch has some nice tokenizing stuff built in, but it's certainly way better than it used to be.
But still, I would say
it's an issue, right? If somebody considers like sub tokens and the other considers full words, you have different events that you are feeding into the system.
But why would you ever need to use two different models like that?
if you are trying to improve the performance of something and all you have are these trained models, like if you're going to train end-to-end, yes, you don't need it. But if you are reusing BERT and then you're trying to blend it together with laser or stuff like that, you will need it.
Mm-hmm. Yeah. Another challenge here is, we have a lot of data for multiple languages, like multilingual BERT, XLMR. These are models that are pre-trained on large amount of data. But then depending on how you build your tokenizer, your sentence piece, your whatever, it depends on the training data that is used to build all these small, codes and vocabulary. So when you are balancing low resource languages versus high resource languages, it's more likely that whole segments of whole words from English are going to be present in the vocabulary, while lower resource languages like Hausa or Nepali will have fewer tokens, complete tokens in the vocabulary. So this creates an imbalance. Lower resource languages will be more fragmented, right, than higher resource language. So determining how to mix the data when building these tokenizers is really important as well. And it's not a I wouldn't say it's like a completely solved problem.
Mariama or Aisha, do you have anything that any comment either about this discussion or any other comment that came through the talk that you would like to add?
Yeah, I can add something. So one of the challenges now we are facing, like some students are working in translation now here, like in their thesis. But now it's like, other than tokenize, I feel like can we like try to learn the similarity between two words? For example, it's like in the pre-processing, I believe it's like more, it's also engineering stuff, but it's like when collecting your data, try to find also when you're building your dictionary or tokenize that data set, try to see like the similarity also. And I think this is one of the challenges, like similarity will lead to also learning the representation of different words. How can we be sure like this one is similar to this?
Okay, thank you. Are there any other closing remarks from anyone? Any other comments? Final comments? We're about to close the panel.
I would like to recommend a book. It's from 1976. It's by the author of Eliza. Eliza, that chatbot that got very popular and then kind of hit an AI winter. I do feel like GPT-3 is... and the book was written a few years before the author died. And it's called Computer Power and Human Reason, From Judgment to Calculation. And it's a philosophical book where the author says, well, I did something that was tricking humans, and humans happily got tricked. Yes, and we discuss all the ethics behind that and why computers lack compassion and things like that. So I found that book very, very interesting, so I highly recommend it.
Sasha, you want to say something?
Pablo, can I ask, besides kind of wanting it to be true, what makes you think that GPT-3, like, I've read all those blog posts that you've read, but I'm still pretty amazed. And I don't feel like it's a bar trick. I feel like actually being unamazed is the kind of more confirmation bias issue. But maybe I'm not seeing something that you're seeing. Like
it's a language model, right? It's predicting based on the past thing.
But what would shock you? I mean, there seems to be aspects of kind of task. It figures out what the task is. It seems to do some sort of inductive reasoning. I mean, there are clear aspects there that are way beyond my expectations of what a language model would learn. And I feel like just to state this is a hoax, it's like, it feels good, but it doesn't seem to be reacting to the evidence.
All right, I'll try to quantify it in a more reasonable way. The main issue is it's giving you the background distribution. Yes.
Sure.
For example, in deep learning systems, there is a system, for example, that predicts messages for highway closings. Yeah. So you have accident reports, and it gives you a nice tweet. Yeah. Well, but the input data doesn't have which lane got closed, so the system guesses it. It just adds, it hallucinates which lane got closed. So this is a similar thing. It's just filling in all the details from this massive amount of, and humans are very predictable. So in general, it guesses right. But communication is not just guessing right. Or maybe it is, and maybe that says we're all completely predestinated.
These claims are not falsifiable, though. Like they're not. I struggle with this. Like you may say, like only humans are able to drive, but clearly predictive models are going to learn how to drive very well. So that's not the boundary. But like what phenomena would it have to do that would where do you feel?
I agree with you. What you describe is it's a very, very valid criticism of my criticism, and we need a falsifiable test to say, well, this thing, even though it's just a language model, it's doing things that you will expect an intelligent being do. And I do think that's a reasonable test. I don't have it right now, but do think that's really worth thinking about it.
I love this topic, and I love this discussion. And I come from a lab that also tends to think that deep learning lacks some things, and I've also been really impressed by the recent advances and progress about what just the language model can do. So I found this extremely interesting. Let me close up just by coming back very briefly to the topic of Latin America and Africa. RIA is obviously an attempt to foster the ecosystem in Latin America and in Mexico. And it takes a huge effort. So I think in Africa, kind of what happened, as Aisha and Mariama said, was Mustafa Cisse, a great researcher, just decided through his network and with a lot of like time to construct that. And part of what we need, I think, in Latin America is something like that. Like and events like this really help, because I feel, for example, I've been trying, probably Sasha hasn't even heard this, but I tried to tell Joshua to have ICLR in Mexico or in Latin America, and he does seem to consider it and says, "Oh, I'll definitely propose it to the committee," and blah blah. And I think things like this do help enhance the chances of doing that. And both Argentina and Uruguay and us have been recently like fostering the ecosystem. But having Africa is very inspiring for us.
Yeah, can I? So just to follow up on that, so I'm on the board of ICLR. We unfortunately didn't have a chance to go to Africa last year, but we hope to go there, and there's a lot of talk on setting that up. And it seems like we're considering Rwanda, so we should talk to Mariama more. But yeah, it would be very exciting to have one in Latin America. I would love that. Nlp next year is in Mexico City, I think. So that'll be one chance to.
Oh, really? I was not aware of that. That's amazing.
Maybe it might be NACL, but one of the
NACL, yeah.
NACL.
Okay.
So
great.
Hopefully we'll be able to go. I'm very, even though I work on virtual conferences, I'm so excited to go to Mexico City. So hopefully.
Nice. Well, on that note, thank you very much for everyone. Really a pleasure, a personal honor, and it's great to have you here in RIA and for this amazing panel. The discussion was really interesting. Thank you, everyone. And now there's a community session continuing in the session section. Please jump there if you want. Thank you, everyone.
Thank you.